Okay, we're going to do some notes here, and it seems like a lot, but honestly, they'll go very quickly. Some of this is review, some of this is new, but it's stuff that you guys definitely need to know before you leave 8th grade. So, probability of a single event. So we're going to say probability is the chance that an event will happen. The probability P that that event will happen is given by the following fraction. So we have the probability of the event is the chances of happening divided by the total chances. So if we wanted to know the percent of something, we would do the division, we'd find the decimal, we'd change it into a percent. Today we're going to keep everything in fractions though, so no worries about that. All right, so when a coin is tossed, how many outcomes are possible? Well, that's easy. There's 2, right? Heads and tails are our only choices. So what's the probability of getting tails? Well, 1 out of 2. See how easy that is, right? All right. When a 6-sided die, a number cube, is rolled, how many outcomes are possible? Well, there are 6, right? 1, 2, 3, 4, 5, and 6. What's the probability of getting an odd number? Well, there are 3 odd numbers out of 6 total numbers. So and then we would simplify that. Our probability is 1/2. See, super easy. All right, suppose a bag contains 4 red, 4 green, and 4 blue marbles. A marble is selected from the bag at random. Determine each probability below. Always simplify. All right, so what's the probability of getting red? Well, there are 4 red out of 12 total marbles. We would simplify, and we'd say we have a 1/3 chance of getting red. How about green? Well, easy. 4 green out of 12 total. Simplify, we get 1/3. How about not blue? So we have 8 marbles that aren't blue out of the 12. So that would be 2/3. So we're just paying attention to what they're asking. That's going to be your biggest mistake, is just not reading this carefully. In this example, there's an equally likely chance that a marble of each color could be selected from the bag because there are the same number of marbles each color. Right? So pretty straightforward, pretty common sense stuff. Let's move on. So this is a single event. Now we're going to talk independent events. We all know what the word independent means, right? It means you're doing things on your own. Things don't affect others, right? So like if I independently decide to go to Starbucks on my way to school, that doesn't affect your day. If I independently decide to open the window in the classroom, right? In theory, it should not affect you unless you're by the window and it's cold. That's a totally different story. Okay, 2 events are called independent if the outcome of the first event does not affect the outcome of the second event. The probability of 2 independent events A and B can be given by the following. So probability of event A times the probability of event B, right? So we multiply the fractions representing the probabilities of each independent event. So if you see this word and here, that's going to be really important here. If you see the word and, you're going to multiply the 2 different events. So we have a spinner here. This is pretty exciting. It's spun twice. Determine each probability below. So what's the probability of getting an 8 and a 5? So 2 times, right? So probability of 8, 1/8. Probability of a 5, 1/8. Probability of an 8 and then a 5, I multiply them, and I get a 1 in 40 chance that that would be the exact spins I would get. 1 out of 40. Oh, excuse me, 40. Why did I put a 5 here? Oh, because it says 5. 1 out of 64 chance. Some of you are probably thinking, get it together, Mrs. Marsh. You're right. Get it together. Okay, how about an odd number? Well, there are 4 odd numbers out of 8. And then how about a 6? Well, there's 1 out of 8. That's a 6. So 4 out of 8, times 1 out of 8 is going to be 5 over 64. What am I doing, you guys? I need to get it together. 4 out of 64, which simplifies then to 1 out of 16. Right? Now some of you are probably thinking, couldn't I have just written 1/2 here, and then that would have made the math a little bit easier? Absolutely, right? You can simplify ahead or at the end. We're going to get to an example here in a little bit where you're not going to want to simplify because we're going to end up adding some things, and of course we need a common denominator. But when we're multiplying, yes, you can simplify as you go. How about the probability of a 1 and not a 2? So the probability of a 1 is 1 out of 8, and not 2 is 7 out of 8. So I would take the 1/8 times the 7/8. Let's see if I can do some math here. 7 out of 64. I can't simplify that. That would be my answer. Okay, so again, we are multiplying because we're talking about this and that, right? And then that. All right, dependent events are a little bit different, okay? 2 events are called dependent if the outcome of the first event does affect the outcome of the second event. The probability of 2 dependent events, A and B, is given by the following. So we have the word and, so we're still going to multiply. But, that's my multiplication symbol. But this is where I think we talked very briefly, like if you don't replace something, and so your denominator changes, right? Because your total changes. All right, so we've got all these socks in a drawer. One sock is selected. It is not replaced. Find the probability below. Since the first sock is not replaced, the first event affects the outcome of the second. These are dependent events, right? If I pull a red sock out, that means I only have 3 red socks left for the second time it happens, and so on. All right, probability of red. We've got this word and again, so we know we're going to multiply. First selection is red. Well, there happen to be 4 red socks out of 18 total socks. It's gone. Second selection, blue. Well, there are 6 blue socks out of now only 17 that are left, right? Because we took away a red sock, so now there's only 17 left. So the probability of a red and then a blue is going to be 4 over 18 times 6 over 17. I can do some fancy cross simplifying, and I'm going to get 4 over 51. So that is the probability of the first sock that I pick is red, the second sock that I pick is blue, knowing that that red one was not replaced. Remember, that's why this denominator changed. All right, how about a red and then not yellow? All right, so red again is 4 out of 18, not yellow. So how many socks are not yellow? Well, there are now, because this red one's gone, right? So my total was 18. I know my total is now 17. And how many socks are left that are not yellow? Well, one of the red ones is gone. So I have 3 red and 6 blue left. So that gives me the 9. Remember, this red one wasn't replaced. 4 out of 18 times 9 out of 17. I'm going to do some fancy cross simplifying. I'm going to get 4 out of 34. Which can still simplify to 217. So the probability of me choosing a red and then a sock that's not yellow is 2 out of 17. Those are the chances. You guys picking up this whole change of the denominator? This one actually affected the numerator because I had 1 less red sock, right? Okay, blue and then blue. All right, well, there's 6 blue out of 18. And then if I'm going to pick another blue, I only have 5 blue left out of 17 total socks. So I'm going to have 6 over 18 times 5 over 17. Can't do any simplifying here, so I've got 30 over, yikes, what is 18 times 17? 306. These can both be divided by 6, so I'm going to get 5 over 51. And some of you might have been like, hey, Mrs. Marsh, you could have simplified this to 1/3. And that's true. right? I don't care when you simplify as long as your answer is simplified. All right, see, we're cruising right along. Last page, mutually exclusive events. Two events are mutually exclusive. If they cannot happen at the same time. For example, rolling a 4 or a 5 on a number cube are mutually exclusive events, as only one number can be obtained each roll, right? I can't roll a die and then get like 4 or 5. Like, that's not a thing, right? The probability of two mutually exclusive events, A or B, is given by the following. Notice we have the word or here. Everybody see that? Probability of A plus probability of B. So as soon as we see that word or, now we're going to add. Okay, so up until now we've been multiplying the events. Now we're going to add them. All right, a card is selected at random from a standard deck of 52 cards. If you're not familiar with a deck of 52 cards, it's okay. I'm going to give you these examples. You're still going to get the idea of what's happening here. But basically, 52 cards, a deck of 52 cards has 4 suits, like so basically 4 shapes or symbols. There are hearts, diamonds, clubs, and spades. And then each of those symbols has ace through king. So it's ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king, right? So there's 13 of each of those symbols. And I know it's kind of hard right now, but if you're not 100% sure, you can Google it, look it up, look up a picture, you can see all the cards I'm talking about, okay? So for some of us, this will be super relevant, some of us maybe not, but it's still a good way to practice mutually exclusive. So we're going to determine each probability below. The probability of an ace or a king. So there are 4 aces out of 52, and there are 4 kings out of 52 cards. So the probability of ace or king is 4 out of 52 plus 4 out of 52. This is where we want common denominators because you know you need them to add. So we wouldn't have wanted to simplify along the way. So then I'm going to get 8 out of 52, which can simplify to 2/13. So the probability of picking an ace or a king out of a deck of cards, just picking one card, is 2 out of 13, right? Okay, how about a 7 of spades or a heart card? So there's only one card in the whole deck that's considered a 7 of spades. There are 13 cards out of the whole deck that are heart cards. So I would add these. I'm going to get 14 out of 52, which simplifies to 7 out of 26. So there are 7 cards every 26 that could possibly be a 7 of spades or a heart card. Yep. That's the probability. A black card or a 4. Okay, well there are 26 black cards, right? Because we have spades and clubs out of 52. We only have four cards because you have the hearts, diamonds, clubs, and spades. That's what you're going to have for all the 4 cards. So I'm going to have 26 out of 52 plus 4 out of 52. I'm going to get 30 out of 52 cards that meet that requirement, and that's going to simplify to 15 out of 26. That's a lot of cards. That's a lot of possibilities. The probability is pretty good for picking one of those cards. Okay, so tomorrow when you come into school, we're going to practice using these. Okay, but I just needed you to have the notes so that tomorrow you can use them to apply to the practice. All right, I hope you guys have a great day. Thank you.